Hey guys, I just wanted to show you an example of a lab. This is a lab that we were going to do on Tuesday. Obviously we didn't get to do it. So what's going to happen is I'm going to show you how this lab works. I'm going to set it up for you and let you see how the breadboard works, all this equipment works. I'm going to do it myself and I'll give you a spreadsheet with the data. Your goal is going to be to take that data and to analyze it. First thing I want to show you is this breadboard. So we come in here and take a look at this breadboard. What the breadboard is for connecting wires together. That's all it really does. Now the breadboard has several, billion little holes on here. And if you look at these rows here, every single one of these 5 holes right here, they're all electrically connected. So if I place a resistor in one of these holes, and I place a resistor in the other hole, they are electrically connected. I don't have to solder them together. I don't have to, glue them together or whatever. Those are now electrically connected. So it's a great way to set things up. These vertical things are called rails. Every single dot in this whole line is electrically connected. Typically, these rails are used for the power and for the ground. And that's what we're using for today. Now, the goal for this lab is to take a look at multiple resistors. Resistors in series and resistors in parallel. Now we went through the equation the other day, went through Kirchhoff's laws and all that, and I hope you're looking at how those things work in the book and on Lanterna. But this lab is designed to have you set up 8 resistors in both series and in parallel for you to look at what the total resistance is, and then make a graph of those things. And I'll type out exactly what I want you to do later. But let me show you what we have set up here. We'll start in series. I've set up this circuit. Already we have set up these 2 multimeters you can see here. This one will measure voltage, this will measure current, and I've set it up like such. Now normally we would have a battery right here. I'm not using a battery, I'm just using a power supply. So just think of this as a battery. But I've wired my ammeter in series. Your ammeter always needs to be wired in series. It has no resistance in it. My voltmeter is in parallel to the rest of the circuit, which is going to be out here. And so all the rest of the resistors I'm going to set out up here. Now in series, of course, we have multiple resistors, one right after the other. Now if we add more and more and more resistors, we know that the total resistance should go up. When I measure the total resistance, it should increase every time I add a resistor. So let me show you how I'll set this circuit up on the board here. Now what I have here, the red is going to my positive power, so this is the positive 3 volts in red, and the black is my negative 3 volts. What I've done is I've run a wire from the ground, not negative 3 volts, 0 volts, from the ground to the blue rail, that's my 0 volts or ground, and then I've run a cable from my positive 3 volts to the red. So any cable right here is positive 3 volts. Any cable here is ground. So what I'm going to do is I'm going to take this is a jumper cable. It's just a cable to connect 2 of these little holes. I'm going to take a cable and I'm just going to move it down here somewhere. So this is now every single hole right here is now powered with 3 volts. My green for ground will be connected in line here. Again, since it's in the same line, it is ground, and I can put the ground down here. Now what's going to happen, I'm going to take these resistors. These resistors are all the same resistance of some unknown value. You're going to find out what that value is. And I'm going to place the resistor one right after the other. So for example, we'll come in positive 3 volts, we'll set up one resistor, and we'll pull that resistor up to the next set of holes. So now these 2 are connected. I know this is hard to see because it's quite small, and now this row is on the other side of that resistor. So now this row, we'll plug another resistor in. It's quite fiddly sometimes. And then I'll just run that resistor over here. It can really be anywhere. So now these 2 resistors are connected at this point, and I'll just do 3 for this example. And so I'll have a third resistor that's connected over here. So now these 2 are connected right here, and we come back to ground. This is now a complete closed circuit. If I go ahead and turn on things, I have my voltage, and I get everything turned on, we should be seeing some current. And through the magic of editing, we're going to see stuff happen right now. Ta-da! It finally works. The issue was the ammeter that was measuring the current, which is supposed to have 0 ohms of resistance, had a blown fuse, which meant that it had infinite resistance and wasn't going to let any current through. As you see in this picture, if this isn't here, then 3 volts can't go anywhere. So that was an issue. So in this situation, I have set up with 3 resistors in series. I can see my voltage over here, 3.05 volts, and I've got my 6.13 milliamps of current. So it's not a lot of current, but that's okay. And what I'll be doing is I'll add 8 resistors. I'll go from 1 to 8 resistors, and I'll give you that data for what the voltage and the current come out to be. Now, if we move to the parallel real quickly, this one's actually a little easier. In parallel, similar kind of setup with my ammeter, my voltmeter, but now my resistors are going to be branching off. And we know when we're in parallel, here's my resistors, and keep going on however long you want. When we're in parallel, the more resistors we add, the less total resistance we should actually have. And so setting up in parallel is actually fairly straightforward. I've already got my 3 volts here. I've got my ground here. And to set things up in parallel, all I'm going to do is just branch from one to the other. Bum, bum. Again, these resistors are sometimes a little fiddly to work with, but okay. And so that's 1 resistor in parallel. Of course, that doesn't make much sense to have 1 resistor in parallel, but whatever. And we can add a second in parallel. I'll just add 2 here. Okay. So we have 2 resistors in parallel, and now I can look at this, and now I'm up at 38 milliamps, quite a bit more. If I want to keep adding more, what I'll do, this little tricky little bit here, is I'm actually going to bridge with another little jumper cable from one, let me get it over here, from one to the other, right there. And I'll grab another one of those and go right here. So now, not only are all 5 of these connected, now all 10 of these are connected because I'm jumping it across, and I can add another resistor here, another resistor here, another resistor here, and so on. So what I'll do is I'll add from 1 to 8 resistors. I'll find the current, I'll find the voltage, and I'll let you know about those. Now, the equation we have here, we've already looked at this equation, is we're going to be looking for the total resistance. The total resistance for series is R1 plus R2 plus R3. For parallel, 1 over the total is 1 over R1 plus 1 over R2, and so on. If we are using identical resistors, which we are in this case, I can simply simplify these equations to this, where N refers to the number of resistors. So if I have 3 resistors, the total resistance will just be whatever 1 resistor is times 3. And same thing for parallel. What I'm going to have you do is I'm going to give you voltages and currents for series and in parallel. Your assignment is going to be, I'm going to have you take those voltages and currents and make 2 graphs. On these graphs, you're going to have number of the number of resistors on the x-axis, because that's independent, that's the one you changed. On the y-axis, I want you to put the total resistance. Now, these 2 graphs should look very different, but what I'm going to ask you to do, and I'll give you more information in the paper I send out, is I'm going to have you use those 2 graphs and maybe even create another one, if you can think about how you want to do that, to first find the resistance of 1 resistor, and 2, verify that these rules are correct. So hopefully you're going to see these rules do end up working in the real world. They may not work out exactly right. There may be some issues with maybe they don't hit the origin, maybe they have a y-intercept of something. We'll talk about those when we meet next time. But the assignment is going to be to write me a little paper explaining first, how do you know what the resistance of these resistors is? And 2, do these resistors follow these Kirchhoff laws? Give you more information as we go. Keep up with things in the book. Keep checking out Lanterna. I hate that we're missing school like this because we do have a lot of stuff to cover, but we'll get this done and we'll get through it. Have a good day.